Hello everyone. In this video, we will discuss the reactions of alkyl halides with a focus on substitution and elimination. By the end of this video, students would be able to differentiate between SN2 and E2 reactions. These are bimolecular reactions that involve alkyl halides. Unimolecular reactions SN1 and E1 will not be discussed in this video. So let's start by reviewing SN2 and E2 reactions. An SN2 reaction is the reaction between an alkyl halide and a nucleophile. The nucleophile in this reaction is usually a strong nucleophile, and the reaction is facilitated in polar aprotic solvents. As far as the mechanism of the reaction is concerned, it involves a concerted process. This means that all bond forming and bond breaking events take place in a single step. In the particular example above, the nucleophile does a backside attack at the alpha carbon of the alkyl halide with a simultaneous loss of the leaving group. This results in the formation of our product where the nucleophile is now connected to the alpha carbon and the halogen is lost as a halide ion. In a case where the alkyl halide is chiral at the alpha carbon, the reaction also proceeds with an inversion of configuration. As far as the reactivity of alkyl halides is concerned, it is determined by steric hindrance at the alpha carbon. So the most reactive alkyl halide is a methyl halide, which exhibits the least amount of steric hindrance at the alpha carbon, and the reactivity decreases in the order of methyl to primary alkyl halides, then secondary alkyl halides, and tertiary alkyl halides, which exhibit the most steric hindrance at the alpha carbon, do not participate in this reaction. An E2 reaction is the reaction between an alkyl halide and a base. The base in this reaction is usually a strong base, and the reaction is facilitated in polar protic solvents. The mechanism of an E2 reaction again involves a concerted process where all bond forming and bond breaking events take place in one step. The transition state leading to the product in an E2 reaction requires an anti-periplanar arrangement between the beta hydrogen and the leaving group, which is the halogen. So what happens in the transition state based on mechanism is the base abstracts the beta hydrogen, and simultaneously the electrons in the sigma bond between the beta carbon and the beta hydrogen drop into the space between the alpha carbon and the beta carbon, and this pushes out the leaving group as a halide ion. This results in the formation of our product, which is an alkene, and it displays a double bond between the alpha carbon and the beta carbon, along with the conjugate acid of the base used and the halide ion. As far as relative reactivity of alkyl halides is concerned, it is determined by the stability of the alkene product that is formed. So in this particular case, tertiary alkyl halides are the most reactive because they result in the more substituted alkene products, and this is followed by secondary alkyl halides and then primary alkyl halides, which usually do not react by E2 mechanisms, although exceptions are known. Before we move on to differentiate between SN2 and E2 reactions, we have to be able to identify reagents as nucleophiles or bases. Nucleophilicity is a kinetic phenomenon, which means it deals with the relative rates of reactions. Basicity, on the other hand, is a thermodynamic phenomenon, and it depends on the situation at equilibrium. The following chart categorizes some of the commonly observed reagents as either strong nucleophiles or strong bases, or weak nucleophiles and weak bases. So as can be seen, alkoxides like potassium T-butoxide or sodium hydroxide is a strong base, but these are really weak nucleophiles. Other alkoxides which are based on smaller alkyl groups like methoxide or ethoxide are both strong bases as well as strong nucleophiles. And solvent molecules like water and methanol are usually weak nucleophiles and weak bases. So with this categorization of reagents into strong bases or strong nucleophiles, we can move on and try to attempt a few problems where we will try to differentiate between SN2 and E2 reactions. When we look at these two reactions, what we notice is that the reagent is identical in both cases, which is sodium methoxide. Now, sodium methoxide can act as a strong nucleophile as well as a strong base. By comparing the alkyl halides, we notice that the alkyl halide in the first reaction is of the primary kind, whereas the alkyl halide in the second reaction is tertiary in nature. Now, primary alkyl halides have a preference to undergo SN2 type reactions with strong nucleophiles. Tertiary alkyl halides, on the other hand, have a preference to undergo E2 reactions with strong bases. Since sodium methoxide can act both as a strong base and a strong nucleophile, the first reaction in this case is going to give us major SN2 product, while the second reaction would give us mainly E2 products. These would be the major products from these reactions. Now, in case of elimination, we would get two products resulting from the loss of the beta hydrogen at each unique beta carbon that's available in the alkyl halide. Continuing on, let's compare the next set of reactions. What we notice here is that our alkyl halide is identical in both cases, and it is secondary in nature. The reagent in the first example here is sodium thiolate, and the second reagent is sodium methoxide. Now, sodium thiolate is a strong nucleophile but a weak base. Sodium methoxide, on the other hand, is a strong base as well as a strong nucleophile. So the result from this reaction is the first of these two would undergo an SN2 kind of reaction, resulting in the formation of the thiol product. The second reaction here would undergo E2 again, because sodium methoxide is a strong base and a strong nucleophile, and secondary alkyl chlorides have a higher preference to undergo E2 reactions. Lastly, let's look at an example where we have a primary alkyl halide, but our reagent is a strong base and a weak nucleophile. In this particular case, since our reagent is a weak nucleophile, even though we are working with a primary alkyl halide, our major product is going to be the elimination product, and the reaction preferred reaction is going to be an E2 reaction. So hopefully these examples give you some idea about how to analyze the reagent and the alkyl halide to predict the outcome under a given scenario. Hopefully this video was helpful and it will help you differentiate between SN2 and E2 reactions as you study these reactions of alkyl halides. Thank you.